meter per second. There's a velocity. I'll write here also clearly. There's a velocity. And this will be the time in seconds. Let me take some other data. Very important, it's going to help us a lot. So let this be the maximum. Let this be 10. Let this be 4. Let this be 8. Let this be 16. Or we'll take some smaller data. It'll be easy for us to plot the graph also. 2, 4, 8. These are the intervals. There's a velocity versus time. Velocity, we know it's a vector quantity. What all we'll get from here? So what are the few questions I'm going to ask is like, can we calculate the distance covered, displacement, acceleration, average speed, average velocity? Can we find out all these things from this graph? Yes, it is. How it is possible? So for this, what happened? We need a small theoretical background. The area under VT graph, what it can be equal to. The area under VT graph, what it can be equal to. For that, let me proceed here. First, we'll have some theoretical background. There's an interval of time, t. There's an initial velocity, u. I do have this curve, no? Let me plot it. There's a final velocity. Okay, there's a velocity, meter per second I'm putting. So this particular area, I'm interested in this area. Are you looking this yellow color shaded region? So the area under the curve, what do it implies? So for that, what is this equation represents? V equal to u+at formula. That's all, no? And this will be like a trapezium, O, A, B, C. Area of trapezium, we'll see what will get it. All of you seeing that yellow color strip is now trapezium. So the area under the trapezium, what it should be equal to? Of into height is OC, sum of parallel sides, OA plus CB. OC must be equal to T, OA must be U, and CB must be equal to V. How I'm writing? There's a height of the trapezium, OC. OA, okay, sum of parallel sides, OA plus CB. Then after this, of into TU, V is U plus AT. So this will become equal to T by 2, I'll write it. T by 2 equal to 2U plus AT. So this should be equal to UT plus AT square. Okay, this is the area of trapezium. Now, what is that UT plus half AT square? So we know from equations of motion, it should be S equal to UT plus half AT square. So in place of UT plus half AT square, what you can write? S. And what is S? S is a displacement. So area of trapezium is nothing but area under curve in VT graph. Area under curve in VT graph. So what is equal to? Is equal to displacement, no? Nothing but. So here afterwards, so we are going to conclude here. If you calculate area under VT graph, what it is equal to? It is equal to indirectly the displacement. This will be best thing which is going to help us a lot rather than writing equation, because finding area under the straight line will be much easier. Determining the area under curve in straight line will be area under the curve. This will be easier. So area of trapezium, area of rectangle, area of square, area of triangle. That'll be much easier. We can determine easily. Okay, let's come similarly for this. I was interested in this one. Okay, let's calculate area. So there are, can we shade out? Okay, there's a one triangle. So altogether, I'll divide this curve, area under this curve into three parts. We can see this. So this is the next. I'm just dividing this particular area into three parts. So that will be easy for us to learn. You can directly get into the calculations part. Okay, some not visible you are telling. Okay, I'll make it thick line. Okay, now. Now get into this one. So I will write, let me indicate this is A1, A2, A3. So what is A1? So from first we'll calculate, see what we'll get it. Area of this triangle, how much it should be equal to? Half into base into height. There's a base, no? 0 to 2. There's a height, half into base into height, plus area of this rectangle. This should be equal to height into base 4 minus 2. Then area of this triangle, this should be equal to half into height 10, 8 minus 4. Half into base into height, no? Okay, let me write it. 10 plus 20. This will be 20. So altogether, this will be 50. This is total area. This A, I'll write it as A1 plus A2 plus A3. How much we got it? The total area under the curve? 50 meters. So this should be equal to the total displacement it is. Total displacement S bar is equal to how much it is? A bar, which is 50 meter I cap. If you know total displacement, can you calculate average velocity? What is average velocity? It should be equal to S bar by T. What is S bar? 50 I cap. What is the time interval? 8. The body is in motion for 8 seconds. So 25 by 4 I cap meter per second. See, so much of information is available. In VT graph, area under VT graph will be equal to area under curve in VT graph is equal to displacement. This much we know it. Then if you know displacement, what you can calculate? Average velocity you can calculate. Then can we calculate any other information? As I want to know the acceleration at 1. So what is the acceleration? The slope. I think everyone knows how to calculate. So what is the acceleration? The slope of this curve. So therefore here the next part will be acceleration. A1 should be equal to 10 minus 0 by 2. 5 meter per second square. This is acceleration at t equal to 1 second. See, not only just displacement, we are able to calculate average velocity. Now the acceleration is what I'm showing. Then what is the acceleration at 3 seconds? Will be 0, no? Because there's no change in velocity. Acceleration for t. Similarly, I want the acceleration at say 5 or 6 or 7 or 8 seconds, anywhere in this region. Uniform retardation it is. So the slope is has to be calculated. So it should be equal to 0 minus 10 by 8 minus 4. What do you mean by negative? It will be retardation. I think I'm displaying everything. See it once. So from VT graph, see, rather than putting theoretically, I'm just took numerical and explaining all the concepts. From VT graph, what all you can find out. Area under curve in VT graph will give displacement. If you know displacement, you'll get average velocity. You can also get the distance covered also. You'll get in acceleration also. You can also calculate even average acceleration also. So from VT graph, what all we can determine? The next question comes. From VT graph, what all we can determine? We can find out. So let me summarize here. From VT graph, means from velocity versus time graph. From velocity versus time graph, what all we can find out? We can find displacement, distance covered, average velocity, average speed, acceleration, instantaneous acceleration, average acceleration. See, I think so much of information is available. It looks very simple curve, but the area under the curve, what happen will indicate so much. Area under the curve, with the help of area under the curve, we can calculate these two. From slope, we'll get this one. From change in velocity by time taken, we'll get average velocity, average acceleration. I'm not saying area under the curve. With area under the curve, we'll get this 4. Let me summarize here. Area under curve. So what about this? Slope of tangent drawn to the curve. This about the average acceleration. What we do is change in velocity by time taken, looking at the data. So much of information is available. So the graphs are very, very important in kinematics, because rather than explaining it, I'll just draw a graph. Now you see what actually, how that physically this motion occurs. Let's see that. Your speed is increasing. If speed increases, then it should be side accelerated motion. No? Speed constant uniform motion. Then speed decreases, so it's a retarding motion. So altogether, how do this motion occurs? We'll take the next plotting of graphs.